Imagine a vast ocean, its surface shimmering under the tropical sun. Beneath the tranquility lies a hidden force, a powerful current that can alter the course of weather patterns across the globe. This force, known as El Niño, is a climate pattern that emerges in the Pacific Ocean, bringing with it a cascade of consequences for life on Earth. From devastating floods to scorching droughts, El Niño's influence is felt far beyond the ocean's edge. It is a stark reminder of the interconnectedness of our planet and the immense power of natural forces. The name El Niño, Spanish for the little boy, might seem innocuous at first. It was coined centuries ago by Peruvian fishermen who noticed the unusually warm waters that appeared around Christmas time. Little did they know that this seemingly local phenomenon was part of a much larger cycle, one that influences weather patterns across the globe. El Niño is a powerful force of nature, capable of unleashing chaos and destruction on a global scale. Understanding El Niño is not just about deciphering complex scientific data, it is about recognizing our planet's delicate balance and the profound ways in which climate shapes life on Earth. The Pacific Ocean, the largest and deepest of Earth's oceans, is a dynamic system. It plays a crucial role in regulating global climate. At the heart of this system lies a natural cycle known as the El Niño Southern Oscillation, or ENSO. This cycle has two extreme phases, El Niño and La Niña. They are like two sides of the same coin, each bringing its own distinct set of weather patterns to different parts of the world. Under normal conditions, trade winds blow from east to west across the equatorial Pacific. These winds push warm surface water towards Indonesia and Australia, allowing cool, nutrient-rich water to well up from the depths off the coast of South America. This process, known as upwelling, supports a rich ecosystem and sustains a thriving fishing industry. El Niño disrupts this delicate balance. During an El Niño event, the trade winds weaken or even reverse direction. This allows warm water that is normally confined to the western Pacific to spread eastward, blanketing the central and eastern equatorial Pacific. As the warm water spreads, it alters atmospheric circulation patterns, triggering a chain reaction of weather events across the globe. El Niño's impacts are not confined to the Pacific Ocean. Its influence stretches across continents, disrupting weather systems and impacting ecosystems thousands of miles away. The shift in ocean temperatures triggers changes in atmospheric circulation, leading to a cascade of unusual weather events worldwide. One of the most well-known impacts of El Niño is increased rainfall along the western coast of South America. Areas that are normally arid may experience torrential downpours and flooding. Meanwhile, on the other side of the Pacific, countries like Indonesia and Australia often face severe droughts. Crops wither, water supplies dwindle, and wildfires become more frequent. El Niño's reach extends far beyond the tropics. It can influence the jet stream, a powerful air current that governs weather patterns in the northern hemisphere. This can lead to warmer than average winters in some regions and colder, wetter winters in others. The effects are unpredictable and can vary from one El Niño event to the next. Section 4. The human cost. Economies and societies adrift. El Niño's impacts are not just meteorological, they are deeply intertwined with human societies and economies. The extreme weather events it triggers can have devastating consequences, particularly for vulnerable communities that rely heavily on agriculture or fishing. Droughts fueled by El Niño can cripple agricultural production, leading to food shortages and soaring prices. Communities dependent on subsistence farming are particularly vulnerable, facing hunger and economic hardship. The loss of crops and livestock can devastate livelihoods and trigger mass migrations. The economic toll of El Niño extends beyond agriculture. Extreme weather can damage infrastructure, disrupt transportation, and strain healthcare systems. The costs of disaster relief and rebuilding can be staggering, hindering economic development and exacerbating existing inequalities. Section 5. Unraveling the enigma, the science behind El Niño. Understanding the science behind El Niño is crucial for predicting its arrival and mitigating its impacts. Scientists monitor a complex interplay of oceanic and atmospheric factors to track the development and evolution of El Niño events. One key indicator is the sea surface temperature in the equatorial Pacific. Satellites and buoys constantly measure ocean temperatures, providing valuable data to scientists. Another crucial factor is the Southern Oscillation, which refers to the atmospheric pressure difference between the eastern and western Pacific. During El Niño, this pressure difference weakens, allowing warm water to flow eastward. Scientists use sophisticated computer models to analyze these and other factors, such as wind patterns and ocean currents. These models help to predict the likelihood of an El Niño event, its potential strength, and its likely impacts on different regions. While predicting El Niño with absolute certainty remains a challenge, our understanding of this complex phenomenon has significantly improved over the years. Section 6. The two faces of change, El Niño versus La Niña. While El Niño brings warmer than average waters to the central and eastern Pacific, its counterpart, La Niña, is characterized by unusually cool ocean temperatures in the same region. La Niña, meaning the little girl in Spanish, is the cool phase of the Enso cycle. It brings its own set of distinct weather patterns, often described as the opposite of El Niño's impacts. During La Niña, the trade winds intensify, pushing warm water westward and strengthening the upwelling of cold water off the coast of South America. This can lead to increased rainfall and flooding in countries like Australia and Indonesia, while the western United States and South America may experience drier conditions. Both El Niño and La Niña are natural climate patterns that have been occurring for centuries. However, their frequency and intensity appear to be changing, potentially due to the influence of climate change. Understanding the interplay between these natural cycles and human-induced climate change is a crucial area of ongoing research. You're watching Astro Vibe, where we explore the universe, from the depths of the oceans to the edges of the cosmos. If you enjoyed this journey, give it a like, share with fellow explorers, and subscribe to stay tuned for more wonders of our planet and beyond. Until next time, keep your curiosity alive.